Fourth grade, here it is, our last lesson in math for this year in fourth grade, chapter 5.5. For our last lesson, we're going to be talking about prime and composite numbers. Okay, so you actually already know what they are, but you didn't know the name of them. So here we are going to talk about prime and composite numbers. So let's go to unlock the problem. Students are arranging square tables to make one larger rectangular table. If the students want to choose from the greatest number of ways to arrange the tables, should they use 12 or 13 square tables? So let's go to the blue box first. It's asking us what are the factors of 12. Now remember, when we ask what are factors of a number, we're not just thinking of a multiplication problem that equals 12. No, we're thinking of all the numbers that can multiply by another number to equal 12. So let's see. We got 1, and we know that 1 times 12 equals 12. What about 2? Yes, 2 times 6 equals 12. What about 3? 3 times 4 equals 12. Is there another number? Well, all there's left is 5, and nothing times 5 equals 12. So that's it. 1, 2, 3, 4, 6, and 12 are factors of 12. So let's go ahead to how to answer it. It says use the grid to show all the possible arrangements of 12 and 13 tables. So now what we're going to do is use these factors of 12 to make basically arrays. So we know that 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4. So we're going to make an array for all of those, and then we're going to see what we can do with 13. What times what equals 13? So we have our first one, 1 and 12, so we can actually cross that out because we did it. Let's do 2 and 6 now. So 2 and 1, 2, 3, 4, 5, 6. And I'm going to write here 2 times 6. Okay, now let's do 3 times 4. 1, 2, 3. 1, 2, 3, 4. 3 times 4. Perfect. We used all of our factors for 12. Now let's see what are our possibilities for 13. Well, we know that every single number has at least 1 times that number as a factor, right? 1 times, well, 12 ends here, so let's do 13 right here. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. 1 times 13. And that's it. We have nothing else that multiplies to give us 13. So there are more ways to rearrange how many tables? 12 or 13? Well, we can rearrange 12 tables in 1, 2, 3 ways, and we can arrange 13 tables one way. So let's go ahead and say that there are more ways to rearrange 12 tables. So we know that there are some numbers that only have 1 or 2 factors rather for that number. So for 13, you only have 1 and 13 as factors. For 12, you have 1, 12, 2, 6, 3, and 4 as factors. That is the difference between prime numbers and composite numbers. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. So an example of that is 13. 13 is a whole number, it's greater than 1, and it only has 2 factors, 1 and itself. Now I don't say 1 because 1 is right here, no. I say 1 because 1 is a number that can multiply by another number to give us that whole number. Okay, and then a composite number is basically what 12 is. A whole number greater than 1 that has more than 2 factors. So this one only has 2 factors. This one can have more than 2 factors. That's the difference between a prime number and a composite number. Exactly 2 factors and more than 2 factors. And an example of a composite number could be 12, it could be 14, it could be even 15. So these are all composite numbers. So I don't want you to think that prime numbers are odd numbers and composite numbers are even numbers. Do not think that. I remember when I was a kid, I used to think that, but that's not right, because 13 is a prime number and it's odd, but 15 is also an odd number, but it's a composite number, because what do we get? How many factors do we have for 15? We have 1 and 15, 3 and 5. That's it. But that's already 1, 2, 3, 4 factors. That's more than 2, right? That's why 15 is a composite number. Okay? So please, please, please make sure that you learn that and memorize that. Prime numbers only have exactly 2 factors. Composite numbers have more than 2 factors. So let's go again, list the factors of 12. We got 1, 2, 3, 4, 6, and 12. For 13, you only have 1 and 13. So 12 is a composite number, and 13 is a prime number. Okay? So go ahead and make sure you guys memorize that. That's what our lesson is about, so let's keep going. You can use divisibility rules to help tell whether a number is prime or composite. If a number is divisible by any number other than 1 and itself, then the number is composite. Okay, so that's basically the same thing we were talking about. Let's see if this is prime or composite. Is 51 divisible by 2? Well, any number divisible by 2 can only be an even number, right? So we know that 51 is not divisible by 2 because this is not even. And that goes back to the divisibility rules, which I'll pop up right here on the screen right now just so you remember what they are. This you guys need to learn, okay? Divisibility rules, please memorize this as well. So the answer is no. It's because it's not even. 2 can only be divisible by even numbers. But is 51 divisible by 3? Yes, it is. Because the rule for divisibility by 3 is if you add the 2 digits and 3 can go into it. So 5 plus 1 equals 6. And 6 is divisible by 3. 3 can go into 6. So that makes it divisible. So 51 is a prime or composite number based off of this information. Well, it's a composite number because it's divisible by, not only is it divisible by 1 in itself, it's also divisible by 3. That makes 3 factors, okay? So if there's more than 2 factors for the number, then it is composite, remember, okay? So let's go ahead and do share and show. Share and show is basically doing what we did for the examples. So the first one says, use the grid to model the factors of 18. Tell whether 18 is prime or composite. So let's think of the factors for 18 first, and then we can draw the boxes. So let's go with the first number is 1. We always know that 1 and itself are factors, so we can start with the first one and the last one. Now let's go to 2. Is anything times 2 equal 18? Yes, 2 times 9 gives us 18. What about 3? Yes, 3 times 6 equals 18. There's no more blanks, so those are all our numbers. So let's go ahead and make our arrays, basically, make our boxes. So we got 1 and 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So here's our first box. Name it 1 times 18. Now let's do 2 times 9, which is going to be right here. 1, 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. 2 times 9. And last we got 3 times 6, which is going to be 1, 2, 3 times 1, 2, 3, 4, 6. There we go. Those are all of our boxes for the factors of 18. So, does it have 2 factors or more than 2 factors? Clearly it has more than 2 factors. It has 1, 2, 3, 4, 5, 6 factors. So is that prime or composite? It's composite. All right, perfect. So let's go ahead down here to numbers 2 through 5, and all we're going to do is write whether the number is prime or composite. Let's look at 11. That even gives us a little hint. Does 11 have other factors besides 1 and itself? Can anything else multiply to give us 11 other than 1 times 11? If you said no, you are correct. No. Oh, that's not what I'm supposed to write. If you said no, you're correct because it is a prime number. It can only be multiplied 1 in itself to give us 11. What about 73? Well, from what we know, things can only multiply to give us 72, and that's pretty much it. So we can try to multiply 3 and 4, like the smaller numbers, to get all the way up there to see if it will give us 73, but I'll tell you right now that the answer is no. Only 1 times 73 gives us 73, so that means it has only 2 factors. It's prime. What about 69? Well, if you figured it out, there are more than 2 factors that multiply to give you 69. You have to work it out to know. You can't just guess. Right now we're going through it together because we have a short amount of time. We got to get through so you guys can do your work. So it is a composite number. Okay, so we have 1 times 69 and 3 times 23 at least. That gives us 69. So I went and I kept multiplying. Actually, I kept dividing 69 by numbers, and I found that 69 divided by 3 gives me 23. So that means that it's another factor. Okay, so this is composite because it has at least 4 factors. And 42, is it prime or composite? It is composite. We know right away, or at least we should know right away, that 7 times 6 equals 42, as well as 1 times 42, as well as 2 times 21. Okay, so we know for sure that there are at least 6 factors for 42, and there you go, it's composite. So now it's time for you to do on your own, which is going to be the same thing that we just did right now for share and show. Tell whether it's prime or composite. Then you're going to do these problem solvings down here. And you are also going to do the extra practice lesson 5.5 as well, because you have more examples over here. Here you're only going to have a few questions to do. So you're going to also have this page on OneNote as well. All right, so go ahead and get on OneNote and start working on prime and composite numbers.